Okay, I'm muting everybody at this point. In case you have any questions through the chat, ping me and let me know. If you have any questions, then I'll try to answer them. Let's see what's covered today. If you go to our portal and under daily batch, since we are only covering these 5 days as a daily batch, I'm planning to cover most of the. No, we covered till day 7. If we are in a daily class, we would have covered till day 6 the content. So today we'll cover the content which is in day 7 and and day 8 actually. Anyway, so today we'll be covering topics on CMM, which is capability maturity model, and there are different levels of 1 to 5, and we'll go through the content as what each level mean. And we'll also see, yesterday we have looked at content like different phases within an SDLC model. Today we'll see different types of SDLC models. We'll talk about each model, their advantages, disadvantages, and how frequently we see a particular model in a particular environment will be talked. And I'll take some examples wherever I can. And at the end, as I told you, we'll talk about advantages and disadvantages. And there are some hybrid models that we need to discuss, which will be a combination of multiple models together within an organization. And now, what will be as a tester, what would be your role in the model? That is, the key content that we'll be covering at the end. So this is very critical to understand the model, because you might be in an environment, the moment you take a project, real-time project, you are given an assignment, they'll give you documents and start, ask you to read and, start writing the test plan and test cases. So you need to understand what type of model it is. So depending on if it's agile, it will be in sprint. So you need to understand how quickly you need to turn in all the artifacts back to the team. Or if it's a waterfall model, you can easily understand like how long, where to start, where to end. There will be multiple types of testing that will be done in a waterfall model, starting with integration, system, and alpha testing, and again UAT integration finally at the end. So what is a capability maturity model? It is a benchmark of measuring the maturity of an organization's software process. It defines, how the organization is structured and what kind of standards and procedures they are following. If you look at small companies which are at least 5 to 10 employees, the capability maturity model will be, generally it will be CMM 1 or, very lowest level, level 1, level 2, like that. If it is at least 50 to 100 people, then it might be a little more, because as the people, the size is bigger, the employee size is bigger, they try to maintain all standards and practices just to, unless they follow the standards and, process, the projects won't be successful. So this particular model is pretty important for any project to be successful in an organization. I worked mostly in a CMM level 5 companies. Only one company which I worked was it was just a couple of developers, me and a CIO. So that might be at a CMM 1. All they need is instant quick results. They deliver the code and they expect you to test as soon as possible. So if you look at CMM maturity model levels, there are 5 different models in it. The one is the lowest level. Okay, and sorry, let me go back. One is the lowest level model. Generally the process, there is no process at all. All you have is a team together working to a project and making sure they deliver the product. All the entire process is focused on a product delivery rather than a process or a standard that need to be followed. Level 2, you will have basic project management. That means it's managed. Somebody is managing the projects, and there is a project manager involved, and a management can be a project manager or can be a resource manager. Now, resource manager is a person who has resources under him that people will report directly to him. Project management might not have all the people reporting to him, but he might get one developer from development team, one tester from testing team, modeling, one person from modeling team, DBA from DBA team, like that. So he'll group all the individual team members and make a project team. So project team is different than a resource team. You might work for a manager who are all QA, but you might work on a project which is completely different and managed by some other person as a project manager. So level 2, you will have basic project management, and somebody who is a director or a manager will manage it. You will have requirements that will be managed. That means requirements will be written, documents will be created, project planning will be done and scheduling, project monitoring and control, making sure we are going in the right direction. If there is any lapse anywhere, we'll try to fix it. Supplier agreement management. So it's focused on end users. So you are delivering either a project or code or services, whatever it is. There's an end user there, and we have that communication. Whatever we have done, we are trying to communicate with him and pass that information. Measurement and analysis to see, some metrics are captured, how much of testing is done, how much is left, these kind of metrics. Process and product quality assurance. As I told you, it's product based company. So you will have to look at a product scenario. Like you develop a product in these kind of organization. It's pretty small. You might have heard as term as startups. Most of the startups will be at level 2, and they will try to maintain documentation, but there might not be too many people who will be doing that. But one person might be working on multiple roles at the same time. Configuration management. So that is one area where we make sure everything is configured, all your hardware is set up, all your software is ready. What do you need to make sure the project success? So at least to the basic level 2 is maintained, most of the organization. And any new startup, just fresh startups, there won't be any documentation or any standard process that will be followed. Those are at level 1. So there is no level 0 here, if you have noticed. In level 2, the end result will be a low quality. Still, there can be a lot of improvements. So quality is low and risk is high. The reason why quality is low is one person might be doing multiple roles at the same time. In the end, what will be the output? It might be a wrong product or not up to the end user standards. In level 3, we will have process standardization. Everything is defined now. In level 3 companies, you will have some set of process are created such a way that you will have requirements, which is also in level 2. Technical solutions. So you will have a technical solution department where you might have architects, designers who have much knowledge to make sure we are going in the right direction. Product integrations. So you will have different systems or applications interacting. So those need to be integrated properly using a middleware, or however they are connected. All applications have to be integrated in a proper fashion. So somebody technical has to guide that. You will do verification and validation, and you will have organizational process focus, organizational process definition, organizational training. That means we will have overall goal of an organization in the big picture, and we define that before we do any project. So we know what is this particular project adding value to the company and how, and we train internal users, internal reps, or any full-time employees to make sure that they are up to standard. So level 3 will have all this content, and you will have integrated project management. That includes, you might have project managers working on one particular application, and in the same, let's say you have a program is generally a very big one where you might have multiple projects in it. So when you say multiple projects, different people will be leading it, will be different project managers. Now how do different project managers come together at the same place? That is a program manager does that. He will make sure all the project managers come together and they share the knowledge, make sure the projects are aligned such a way that end result is success of a program. So in level 3 all this happens. And there is risk management. We will have a documentation on risk. What are the risks? What might happen? How do we make sure that risks are mitigated? decision analysis and resolution. So what type of decisions we can take, and if suddenly you have a hardware or you need to replace something, whether you need to invest or not, or whether we need to buy a particular new software for this particular project, you need to have that information. So decision analysis and resolution is also maintained. Integrated teaming, organization environment for integration, and integrate supplier management. So everything, it has a certain level where we have enough information, but again it's not like 100%, where we are making sure we are improving at every project level. At most of the companies, majority of the companies will be at level 3. There is a medium quality and medium risk also. In level 4, which are like the big Fortune 50 companies, will be at level 4 and level 5. When you are at level 4, it's quantitatively managed. What does it mean? That means you are measuring the process performance. Based on this process, are you getting any returns? You're making sure you're following certain standards and processes. Is it helping you or not? And making sure you correct it and move towards continuous improvement. So if there is any gaps there, we need to fix it. Like documentation is not written properly, or requirements are not explicitly written. Those need to be defined. That will happen in level 4. And all this feedback will be taken and made sure that we create the right requirements and the right content in the documentation without any bugs. So level 4 also will have higher quality, and there is low risk. Because of high quality, there is low risk. So Hiral, are you on the call? I see that you have left. Hiral, you there? Okay. In level 5, you have the highest quality there, and now at this stage we have organizational innovation and deployment. That means you talk about continuous improvement all the time. Now you don't test only in QA environment. You try to test in dev environment also. That means QA, they will create some regression test suite. The moment a new project is in development stage, we run the regression suite on the development server itself to make sure whether the sanity is tested upfront, and the new code can be delivered into QA before even testing it in QA. So continuous improvement is to make sure, and we are not focusing on where to test, what to test, but we are focusing on the quality and upfront and catching these bugs well in advance. Level 5, there are only very few companies who will be at level 5. Something like IBM, which has like a rational unified process, and AT&T are very, very big companies. Most of companies will be at level 3 and level 4. Level 4 is also very difficult to achieve. Okay. Any questions? So CMM levels are important to know from an understanding standpoint. Like you need to able to explain like what is level 3 versus level 2 versus of all these different levels. Other than that, we don't delve into details on our regular day-to-day job. So this is another graphical information here. Process level 1, you will have process unpredictable, poorly controlled and reactive. In simple terms, it's at the initial stage. In level 2, the process is characterized for projects and is often reactive. That means wherever bugs you find, you try to react to it. You are not proactive. If you find bugs, you test it. If you don't, you don't. If there is a mess up, documentation is not clear, then you try to correct those based on, but you are not following certain standards to make sure it's clear. Level 3, the process is characterized for the organization and is proactive. That means level 3 is at least a level where it's minimal from a standpoint if organization has to succeed, because there won't be one project, there will be multiple projects across multiple departments all going at the same time. How do you coordinate? How do you make sure they are in the right direction? So level 3 is that, and level 4 is process measured and controlled. That means you have a process, you follow everything, first the requirements are created, then the design documents are created, analysis done, then the coding, then the testing. So everything goes in an order, and we are making sure, are we finding any design issues in development phase, are we finding any design issues in testing phase. Based on, we are measuring that. That means our process is not accurate. That means we are not fixing the issues upfront in the design phase itself. Fifth, level 5, as I told you, it is focused more on the continuous process improvement. So every time you want to improve and go towards the perfection of the model. Unless the process is 100% perfect and foolproof, you won't have the right document. So if the level 5 is set up, they have to maintain it. Organization, when it reaches level 5, it has to maintain it. Maintaining means that every team will have to follow certain standards and procedures. They have to report, bugs are reported. If there is any change in a document, that has to go to change management process. As I told you, they will request a change ticket. If there is any risk, they will go to risk management process, configuration management. So these are the extra things, all the project, your QA managers will expect from you. You need to understand these terminology if you have, working on a QA environment. Now let's get to the different types of models that we have. We have many models, and the oldest and the traditional one is a waterfall model. Just like a waterfall starting at a higher level, as the water flows down, it is named exactly in that fashion, in a waterfall model. The waterfall approach is the first process model to be introduced, way old back, not just for IT, it was for some other projects back in 70s. So what are the different phases in waterfall model? You have a requirement gathering and analysis, you have a design, you have implementation, testing, and deployment, which is the production, implementation, and testing and maintenance at the last stage. So you heard about these phases yesterday when we talked about planning, analysis, design, implementation, and maintenance. So that is little elaborated. That is a standard traditional model. Any model should have these phases, the 5 phases. In waterfall, you have 1 or 2 phases extra, but they are split. But everything is going in a sequential order. Once requirement analysis, gathering analysis is completely done, like you create all the requirement documents, then only you go to design. You won't start design before completing the requirement process. Or at least if you're done with 70 to 80% of requirements gathering, then only you go to system design. What is requirements gathering? Okay, now we do feasibility analysis. That means project manager, business, they say, okay, we need to develop this product. Let's take an example of iPhone. Let's build iPhone 6. Okay, that is the business, the project that Apple might have done sometime back. iPhone 6 is coming in September. Now, the next step is, what are the requirements? Now, they will reach out to each individual teams. Like iPhone might be maintained by a particular business team who knows in and outs of iPhone, not the technical information, but at least like the features and the capabilities of iPhone. So they will reach out to them. They will gather the requirements. They will interview them. The business analyst, first the business will say, okay, let's do this project. Next thing, the project manager will come into picture. He'll start doing the feasibility analysis. He'll look at the budget. He'll look at the resources. He will look at the time and everything, scheduling. Then he will hand it over to business analyst. He will work in the parallel. At the same time, business analyst will also take control of gathering the requirements. They will interview all the business people and start creating documentation. Now, this is not a new product. It's an existing product, but it's a complete revamp of the features. So when you try to do a revamp of the features, you need to understand what is existing before. Then only they can provide a better product. So they capture all the requirements. Now they will look at whether it's feasible or not. Feasibility study comes into picture. Can these requirements be implemented in this particular product? They don't care about testing or anything at this stage. All they care is whether this product can be successful with these features. What are the features we want? How do we develop? What needs to be done is a different story again. Gathering and analysis is at a very high level. And when we do this, capture all the information and realize, oh, this is not possible, then the project will be scrapped then and there. You don't invest any more money. But if you realize that you can continue with the project, then only it will go to design phase. In the design phase, now we have everything in a simple sentence, the business, we have business rules and business requirements. Now you need to create a design. You might create a use case diagrams. You need architectural information. All the information that is technical will be captured in the design phase. Once you have all this content and you know what all systems are impacted. Now when you use iPhone, that means you have so many features in it. You check mails, you know so much content, and also that will interact with Apple also. You have to, let's say iPhone 6 comes into picture, and it also need to have an icon for App Store. That App Store should be working properly. Otherwise, Apple can't sell any apps. So in order to do that, they need to make sure that is also incorporated. So design has to happen for that also. So what I'm saying is you need to make sure existing content is still there, the majority core components, and also the new features. In implementation, once you have everything, then you start writing the code, then we do the testing, test plan and everything. In testing phase, we'll start doing our execution. Finally, once every testing is done, not only system testing, user acceptance testing, performance testing, all different types of testing are done, then all the code goes to production, or the Apple product goes to production, manufacture. And finally, once you have the product out, in a product, do you have maintenance? There might be a chance. I mean, some of the features might be defective. They will have to fix it, and they will have to either recall or send new software, push the software to the devices to upgrade it. What are these new iOS versions of iOS push to the iPhones is nothing but fixes of the existing code. That is happening in the maintenance. Okay, I have explained in detail. Now I am going to read the statements of within the content within each phase. Stop me if you have any questions here. This is very important. In requirements phase, requirements of the system to be developed are captured in this phase. We know that. Business requirements, system requirements also. System requirements will be in design mostly. Now requirements are set of functionalities and constraints that the end user who will be using the system expects from the system. Finally, a requirement specification document is created which serves the purpose of guideline for the next phase of the model. So once you capture and you put it in a document so that it's used for the next phase. So system and software design phase. Before a starting of actual coding, it is highly important to understand what we are going to create and what it should look like. So you create wireframes, you create layouts, you create the flow of the data, like what might happen in a certain scenario, and all this will come under design phase. The requirement specifications from the first phase are studied in this phase, and system design is prepared. The system design specifications serve as input for the next phase of the model. What is the next phase after design? What is the next phase after design? Implementation. In implementation phase, we get all the design documents. The work is divided in modules or units, and actual coding is started. Now you have different units that will be created. Those are either created as individual pieces, and that coding will start. Then those are called as units. That's why when they test a unit, it's called unit testing. And unit testing is also called as white box testing and also gray box testing. Okay, unit testing mainly verifies if the modules or units meet their specification based on the requirements. These units are integrated into a complete system during integration phase and tested to check if all modules or units coordinate between each other as per the and the system as a whole behaves as per the specifications. After successfully testing the software, it is delivered to the customer. So as you understand here, the big important that is happening here in the implementation phase is you're building all these units, and all these units make up a system. Okay, then the system will behave as a whole, and that is delivered to the customer. Does anybody has any questions so far? What in maintenance phase, this phase of the waterfall model is virtually never ending phase, very long. So in waterfall model, what will happen is each phase has to happen in a serialized fashion. When we pursue serialized fashion, it takes each phase takes too long to complete. Requirement phase, to capture the right set of requirements, we might take months together. Once we have all the requirements, design takes few more months, then actual coding, then testing, then finally the maintenance. In maintenance, if you still miss some requirements, what is the state of the project? You are over budget, you already consume so much money, time, resources to for the project, but still there are some defects, which is not good. When you say defects can be in the requirements gathering also. If the business analyst doesn't ask the right questions, then he might not capture the right requirements. But how do you as a tester identify them? It's very difficult. Unless you understand the full scope of the business, you can't catch a bug in the requirement that is captured. Most of the time they will be right, 90%, but there will be a 10 to 20% error actually, of cases of not capturing the requirements properly. So in maintenance, this is a very long process, maintenance process. There will be lots of tickets, and we keep working on tickets, making sure those issues are fixed. Generally, problems with the system developed which are not found during the development life cycle come up after its practical use starts. That means actual users will, when they start using the application, that's when all these issues pop up. So the issues are related to system, and they are solved after the deployment of the system in the production environment. That's why it's called a deployment or maintenance phase, post deployment. Okay. Now you see that everything is serialized, everything is so lengthy and time consuming. Now what are the advantages of this model? The advantage of waterfall development is that it allows departmentalization and managerial control. That means when requirements are started, you might be involved only 10 to 20% of your time allocation. You might be working on 5 different projects at the same time, and you might be just going through the requirement sessions or gathering some content like that. Or you might be testing something else and also attending the training meeting sessions for this particular project in the requirements phase or a design phase. That's the advantage of waterfall. So it's departmentalized. So once you don't start working at that stage, a schedule can be set with deadlines for each stage of development. That means every stage, unless the requirements are completed and made sure all are captured and signed off. I mentioned this word in the past. Signed off is you're agreeing to whatever the business analyst has captured, or the architect has created, or the system analyst that he has created the requirements. That is a sign off. So you put a schedule in the project plan. By this time, I need to finish all the requirements. By next time, I need to finish all the design documents, and you're making sure the schedule is met. It's just like a car in a car wash. Everything goes in stage. Development moves from concept through design, implementation, testing, installation, troubleshooting, and ends up at operation and maintenance. Okay. Each phase of development proceeds in strict order without any overlapping or iterative steps. Notice these points. Now, what are the disadvantages? There are many disadvantages in waterfall. The disadvantage of waterfall development is it does not allow much reflection or revision. You're not trying to fix any requirements that are not captured properly, or any issues that you find, you're not doing it in waterfall. You only, while you test, then only figure that out. But in the meantime, if you spend 1 year on a project, what is the situation? You're over budget by now. Once an application is in testing stage, it is very difficult to go back and change something. Alternatives to the waterfall model include joint application development, rapid application development, sync and stabilize. So there are different types of models. These are all IBM models. Okay, IBM has created certain models called joint application or rapid application development or RUP, rational unified process, to make sure everyone come together, get everything done quickly. There are many problems also in waterfall model. Problem one, customers don't know what they want. Okay, if by 1 year back they might ask something, after 1 year their thought process might totally change. They might say, we didn't ask these requirements, we asked something else, but you developed some other product, should we pay for it? Problem two, requirements change during the course of the project. There might be requirements which are captured in the requirements phase, but requirements might change when we didn't capture properly, but the customer explained all the requirements in a correct fashion, but we didn't capture all the requirements. Those requirements might change. Customers might have unreasonable timelines. So your end customers will set up the deadlines. Like, I need within next year, I need this product ready. Communication gaps exist between customers, engineers, and project managers. So in some cases, when you are delivering some solution to some other company, they are your end customers. When you are doing that, their team and our team will get involved, go into the discussions in the analysis and design, and finally the project will be completed. But there might be so much communication gap because they might be following a different process, we might be following a different process, and in waterfall model it's a big headache. The development team doesn't understand the politics of customers organization. So development focus is to develop. I don't care whether is this the product you wanted or not, but I'll keep developing in this fashion, and you will know whether he has followed the right development practices or developed the right product after the testing. So by the time we have incurred so much amount on the budget, again I'm going back to budget every time, because projects are always measured by budget. A successful project or unsuccessful is based on how much time you have took for a project, within what budget, how many resources, whether you met your expectations or not. Okay. So these are some of the problems. There might be more problems. Now, when to use waterfall model? Seeing at this, we see that there are it's like a big elephant which walks very slowly. But to move it, it's very difficult. Now, why really we need to use? Do we really need to use waterfall model? Can't we use something else? Now, in waterfall model, there are some advantages. When you have all the requirements clearly known and defined, and when the product definition is stable, like what exactly you want. Let's say I want to design a phone which has similar features like iPhone. That is a vague statement of requirement. There are so many features in iPhone. Which feature are we talking about? So when those are vague, you can't use a waterfall model, because you want to change the requirements along the way. When technology is really understood, when a new version of an existing product, porting an existing product to a new platform, that's when you use waterfall model. When we have enough information, when the product definition is clear, when you have clear idea of all the technology that is involved in your project, whether you need application server, you need web server, you need database server, how are these connected, and are these interacting with the end user system, and how is the data flowing through, are we generating a feed to them, or they are generating a feed to you. When all this is understood, that becomes part of the technology. And if you have an existing product and you are trying to build a new version of existing product, because when you do that, you already have a stable release already done. So all you need to do make sure is the new features are captured properly, and do some regression testing on all the core content, or if there is an porting of an existing product to a new platform. Okay, in these cases you use waterfall model. But waterfall models are generally very slow, time consuming, and for testers it's relaxing. You don't need to rush through and get everything done as quickly as possible. You will have ample time to create your test plans, test cases, or test strategy, and any generating the test data, you'll have ample time to succeed. But in other models, it will be pretty rapid. Let's look at other models. Iterative model. What is iterative model? In the word itself, iterative, it's like multiple iterations. Means multiple times we do the same thing again, just like regression, but it's not actual regression. In iterative model, you go through certain steps and they come back to the same place again. As you can see here, it starts at the requirements phase, then it goes to design, then implementation and test, then review. After review, you will already have a product. If the product is good, you say it's completed. If there are some issues, you go to requirements phase again. Okay, in iterative, you make sure you get the final product completely done until it's completely captured and done. You don't end the project. So one cycle of iterative model is pretty good if we complete in one cycle. If there are 2 or 3 cycles, that means we didn't capture the requirements properly, or the design is not done properly. Coding might have some issues. Okay. An iterative lifecycle model does not attempt to start with a full specification of requirements. You start with some set of requirements. Whatever you know, you start with it and keep developing on top of it. Instead, development begins by specifying and implementing just part of the software, which can then be reviewed in order to identify further requirements. So, yesterday I took an example of a website, a portal which has content that is, there are many core components that need to be fixed. In this one, most of the front end has to be fixed, but the back end is working properly. So in this case, we have to go through iteration model only to make sure you have all the data information is created here. And this process repeated producing a new version of software for each cycle of the model. So you go through one cycle, create one version of software, then go through another cycle and create another version of software. So when you do version, there might be like the minor releases, not the complete release. Once you have the final product completely done, then it's the actual version of the particular product or a software application. So I've put some statements here. I'm just reading through it, and stop me if you can. For each cycle of the model, a decision has to be made as to whether the software produced by cycle will be discarded or not, or kept as a starting point for the next cycle. Okay, that means in each model, you need to identify whether we can continue or whether they need to be discarded and start from scratch again. Eventually, a point will be reached where the requirements are complete and software can be delivered. So by doing multiple iterations, you realize what you really need, and you can end it when all the requirements are totally complete. The iterative lifecycle model can be likened to producing software by successive approximation. So you go with approximate requirements, not the actual requirements, but you go through multiple cycles. But finally, you will have a software that is completely done. But you will have ample opportunity to go into multiple cycles. That gives an advantage. Now, are you spending more budget to this? It's possible. Like if your waterfall model is 1 year, okay, and in iterative model you do like 3 or 4 iterations, which are 3 months each approximately. It's coming to the same stage. But what if you capture all the requirements correctly in the first or 2 cycles? It will be done in 6 months. So you saved 6 months of your time. That's the advantage of iterative model. Okay. Now, going to the V model, this is a different type of model. Okay, before proceeding with this model, let's take a quick 5-minute break. Does anybody has any question so far? Okay, let's halt here for 5 minutes and we'll come back again, then continue with the class again. Okay, the V model is little different than the iterative or the waterfall. Does anybody has any questions on iterative or waterfall? In iterative, the best example, all these models they don't need to be in a IT industry. They can be anywhere. So you might have heard about manufacturing. Okay, they develop products, but they might not develop a particular product. Like casting, you might have heard about some material underneath the car to support some of the key parts. Those are molded. They put it in a mold. They heat it, they develop it. Once the design is good, they do some tests on it. If the part is good, then they will implement as a real. Otherwise, they continue the testing as long as the product is stable and has the right results they wanted to the test. So in order to do that, they go through multiple iterations while creating that kind of parts, mechanical parts. So that is where iteration might be used. In software, there might be scenarios where iteration is used, where we have a situation where we don't know all the requirements, but we want to take a heads up to move with the requirements whatever we know. And if you look at it, iterative is no different than waterfall. In some cases, waterfall you do after you know all the requirements. Iterative you start with, even if you know few requirements, you start immediately on it and try to complete it until you have all the requirements. So in some cases, iterative might be more costly than waterfall. If we keep on going through the multiple cycles, we should try to avoid multiple cycles as we can. In a V model, it's a little different now. In a V model, it's just like V, the structure, as we know, we start with requirement and analysis phase, design and architecture design. All this comes under design, and we go into coding, which is the implementation. After coding, we go to unit testing, integration testing, system testing, then your user acceptance testing, then finally deployment into production. So just like V, as soon as the requirements are created here, what we do is we test it. Initial instant, we try to test the requirements. How do we test it without having any product available? So we make sure, we might not be doing a validation, we might be doing a verification at this stage to make sure, a static analysis to make sure we capture all the requirements, or whether a particular requirement is feasible. If the application already exists, we might run through some of the examples and make sure that is tested. So the acceptance testing design will be created first, like how to test this the moment we have some requirements. So hotels.com, if it comes up with a feature to have chat in their web portal, okay, chatting, and they want to make sure they provide chatting feature to all the customers who browse the hotels on their site. Now they come up with a design, that is a requirement. They come up with a test design that, there are a bunch of requirements there. We create test design there. Once the test design is created, you don't have the product ready yet, but you build these test cases and be ready. The moment these test cases are created, then the requirement phase will move towards system design. And when the system design is completed, then you create system test design again. There might be multiple systems involved in this. The chat window which you wanted to provide to your customers on hotels.com might have multiple applications. So for each application or the system, you create separate test design again. And then once you're complete with all the different types of test design, then you go towards architecture design. When you talk about architecture design, it's more technical in detail. How many tables, what tables, how the tables are interacting, how the data is flowing, and what are the web servers, application servers, what kind of technology do we need to use to parse messages. All this will come under architecture design again. So you don't create any test design for architecture part, because mostly it's technical. After you have the technical information, you have the module design. This is where you have wireframes or layouts and also some other content which might be in the code. May not be directly pictorial or graphical information, can be a code level. This is where developers start getting involved, and they will create some unit test case here. And after system test design, QA also will prepare integration test design here. So we create these test cases and keep it ready. We don't execute yet because the product is not there. Once a module is designed and now the coding starts. Now how to design the module will be discussed in here, and what units and how they have to be done will be done in the coding one by one, unit by unit. Now coding is done for one unit. Now unit testing will start for that particular unit. The moment multiple units are complete and that particular system is done, now integration testing is done to make sure all the units are working in tandem or in sync. Okay. Now once all these applications are working, integrated, and all the units are working, then system testing will come into picture, where you will have more functional related testing. You have created test case already. Now you are executing. You are not waiting for the test phase at all here in V model. You are creating your test case very well in the beginning. That way you don't lose the focus of the actual testing scenario and testing scope, like what you need to create. By the time we reach acceptance testing, we know that we have created some acceptance test design already ready. All we need to do is execute here. So V model is much better than, if you look at compare the three models that we discussed so far till now, this is much better because we have created a test case. We know what to test, what we really need. What is test? You're making sure those are met to the with the all the application meets the correct requirements, how the business wants it or the end customer wants it. Now instead of moving in a linear way in one direction, we are going in a bent upwards fashion. The V model demonstrates the relationships between each phase of development life cycle and its associated phase of testing. So as you see, testing plays a critical role in V model. And I've seen projects, I've worked on many projects in V model, they're pretty successful. And now as a tester, you might ask me a question like, should we get involved in writing acceptance test cases? Should we write involved in unit test case? We don't. Your role might be only till here. You might create test cases here and execute them. So system tester will come in picture here. Beta tester and all business testers will come here. Developers will unit test their code. They do this here. So this is dev. This is business. I am calling business because most of the business users will do unit testing because they want to test from a business standpoint, not a technical standpoint. What do you mean by technical or business standpoint? You want to see that the focus of the application is whether it's satisfying the business requirements or not. How it's being satisfied, they don't care. All they need is the business. Can they sell this business to their customers or the application? Okay. Any questions? Unless you ask me, I don't know whether you understood or not. So I'll keep on going. Stop me. Through chat, I've muted you. Through chat, just ping me if you have a question, then I'll unmute you. Now in V model, user acceptance tests are designed through requirements phase, during requirements phase, and system testing is designed during the system design phase, as we have discussed and talked about. Now if you look at here in V model, project and requirements planning, what do we do there? We allocate resources there. In product requirements and specification analysis, we prepare the complete specification of the software system. Specification or business requirements documents. Architecture or high level design defines how software functions to fulfill the design. So this is all technical information. Yesterday I showed you a document which had so much technical language there that those will be architectural documents or SAD or software architectural documents. Let me write down here SAD. So in some cases they are called as SAD, software architectural design documents. Those will be created at this stage. In detailed design, this is where you will have more technical information. Might not be architectural level, can be at development level or technical, design level. Production, operation and maintenance. This is where we provide for enhancements and corrections. Since it's we start here and we are coming like this. So we came here, then we do unit testing. In unit testing, we are checking each module acts as expected. Coding, we do that. Integration and testing, check that modules interconnect correctly. Then system and acceptance testing, we do all testing, different combination scenarios with all test data. Then we go to production. So this is exactly like the V shape. So that completes the V model. Let's see if there are any advantage or disadvantage for this. There are some advantages and disadvantages. So advantage is emphasize planning for verification and validation of product in early stage of product development. So as we have spoken, as we have talked about some of the content of verification or static analysis, we said we don't have the product yet, but we go through the requirements and prepare the test cases, user acceptance test cases. So that comes under verification, some of the business level testing. Validation is when we actually do the testing once the code is ready. Each deliverable must be testable. That means any requirement or any related document that needs to be testable. Project management can track progress by milestones because we have steps, and if you find any issues in any of the design, what you do, you try to go back and fix it. Disadvantage, does not easily handle concurrent events, does not handle iterations or phases, does not easily handle dynamic changes in requirements, does not contain risk analysis and activities. So do you do like an iterative model where you go and do multiple fixes? You don't do that. All you need to do is you can only fix one flow of the design and coding, then going back to the deployment stage. But you can update your design then and there. If you have architectural design, and then you can update your system design. So while you work on architect design and when you write the scenarios, you understood that what's missing, what's available there. So those are the advantages and disadvantages. Now when to use V model? V model is a very excellent choice, and most of the systems which require high reliability, they use V models. Example is hospital patient control applications, where a simple application captures all patient related information in the hospital. All requirements are known upfront, when it can be modified to handle changing requirements beyond analysis phase. Okay. Solution and technology are known. So in other models, you don't know, you don't have all the requirements upfront. In waterfall, once you have all, then only you start. But in V model, once you know all the requirements upfront, just like waterfall, you can go through V model itself to have better high reliability. Why high reliability? Because you are already creating the test design documents. You understand what is missing. The missing components will be easily captured, and you can update the design then and there. Okay. I'm going a little quick here. With all the modules, there are another 22 slides. Spiral model. The spiral model, also known as spiral life cycle model, is a systems development method. As you can see, it's in a spiral way. So first step, we start with requirements. It's reviewed. Then we go through create a prototype, and we do risk analysis, like how much of it is complete. Then we look at some more concepts like design and everything. Then we develop it. Once we develop it, we create another prototype too. Then it goes in a spiral fashion until you have the final product. So I'll ask you a simple question here. Which model which is closer to spiral model so far that we have discussed? There are three models we have discussed. So which of those three models is closer to spiral model? You can type your answer. Iterative is closer to the spiral model because we are going in an iterative fashion. We create a prototype, work on it, we go to prototype, again we work on it. So it goes in multiple iterations until we get a final product. V model doesn't go through multiple iterations. V model goes in one direction. So if you look at the picture for V model, you are going downwards then upwards. Only in this direction then upwards, but you are not going in iterative fashion. Iterative model is the one which is going in a circular fashion. Spiral is pretty much the same. Now in this case, instead of one circle which is rotating here and with the partial requirements, now you are creating a prototype, fixing it and going like that. And spiral, and it's also there is another model called prototyping model which will be pretty similar, where you develop the prototype and keep on building the prototype. Now where is spiral model really used? It is intended for large projects, complicated projects where you can't deliver the application or product instantly. You might have to go through multiple cycles to build it slowly, one by one. That's when you use spiral model. Now what are the steps? There are different steps that we need to follow in the spiral model. In the first step is system requirements are defined in as much detail as possible. This usually involves interviewing a number of users representing all the external or internal users and other aspects of the existing system. That means, as I told you, business analysts will interview all the business stakeholders, all the business managers, and they get the requirements. When we say internal, these are the internal people. When we say external, there might be end customers. So if end customers are paying us money to build a product, they will also have to give us the requirements. So for spiral model, we have to get all that requirements clearly defined. Then a preliminary design is created for the new system. A first prototype of the new system is constructed for the preliminary design. What is the advantage of creating a prototype? We are giving upfront information to our customer or the business what we are planning to create. That gives ample advantage to improve it and make it much better. So the prototype is built, then we present it. This is usually a scaled down system and represent an approximation of characteristics of the final product. So I'm using a particular set of statements here. There is a method called approximation method. That means we are trying to build an application which is closer to the final product. By approximating, assuming that this is the final product, we keep on building it. That is approximation method. So when you build this particular prototype, you go in multiple stages to build it, and spiral model comes into picture in those kinds of scenarios. Fourth step, a second prototype is evolved by a fourfold procedure. Again, we start with evaluating the first prototype in terms of its strengths, weaknesses and risks, defining the requirements of the second prototype. Now requirements are redefined again, planning and designing the second prototype, constructing and testing the second prototype. Now we have the second prototype done and ready. What do? We present it to our customer and or the business and let them know, okay, we have built this application based on your requirements. Now tell us, review it and tell us what is working versus what is not working, and is this what you really intended. At the customer's option, the entire project can be aborted. Like if they think their prototype is not what they really wanted, or if it's taking too long to build this product, they'll scrap it. They don't want to spend too much money on it. Otherwise, if they like the product, it will go into another prototype. Or if they think this is the final product, spiral model ends there. So if the prototype is good, the existing prototype is evaluated in the same manner as the first prototype. Then again we go through those 4 steps again, one by one. What are those 4 steps? We evaluate the existing prototype, which might be the second prototype. Then we go through the requirements of that particular prototype. Then planning and designing, again construction and testing. So we are going in multiple cycles here to build a final product. Now the only difference here is in iterative model versus spiral model. In iterative we don't have all the requirements, but in spiral model we have all the requirements, not partial requirements. We think when we start, we think we have all the requirements, but we don't know what is missing there. I've shown you a picture from the first day's class where a customer wants something, but we build something else. Exactly, spiral model will fix those kind of issues, and we'll eventually save a lot of money. So once the final prototype is approved and done, then we call it as a final system. Then it's constructed, and based on this refined prototype, it is thoroughly evaluated and tested, and it's put into production. Now what are the advantages and disadvantages of spiral model? The estimates, budget, schedule, etc. become more realistic as work progresses because important issues are discovered earlier. It is more able to cope with the changes that software development generally entails. So there the change management is very easy. You create change, you don't need to go to create change tickets. You can modify the prototype itself or modify the requirements itself. You don't need to modify the existing requirements. Software engineers, they can create the prototype and they can keep on working on it. That's a disadvantage actually. I don't know why I put it in an advantage, but it should be a disadvantage. So this particular statement here, software engineers can get their hands in and start working on a project earlier, but at the same time they might keep working on the same prototype again and again. They might not develop. If it's that's a disadvantage. And in some cases, risk of not meeting budget or schedule, because if you want to go through multiple prototypes, we might end up with a bigger cycle, and finally that prototype might be scrapped at any time. Any questions on spiral model? It's like iterative, but we don't change the requirements anywhere. We think we have all the requirements, no partial requirements here. Moving on to the RAD model. RAD model, it's one of the model developed by IBM. RAD, JAD session. JAD session is called Joint Application Design Sessions. RAD is Rapid Application Development. Okay, and let me write down here. So JAD is Joint Application Design Sessions. That means all the teams will come together, discuss and go through the requirements and try to re-engineer, and they create all this requirement document, design documents all together. Then the coding starts. They'll spend a lot of time in JAD sessions to make sure all the requirements are captured upfront. If it's a complex project, for small projects we don't do JAD sessions. It might be iterative model. In RAD model, Rapid Application Development, it's a concept that products can be developed faster and of higher quality through gathering requirements using workshops or focus groups, just like I've talked about in JAD. Prototyping and early reiterative user testing of designs, the reuse of software components, rigidly placed schedule that defers design improvements to the next product version, less formality in reviews and other team communication. So we start in this fashion. We go through JAD session, document the requirements, design, develop, test, again we review it. So it goes through a cycle here. And before this happens, we come up with the planning, then the cycle goes, and then finally we deploy it. Traditional, we go one by one in the same order. Waterfall model goes in this fashion: planning, analysis, design, building, testing. RAD, we go through a cycle. Planning will be done upfront, that sticks as is, but in the middle, that will be upgraded and updated based on the requirements. Then finally, once we have final product, then we go to deployment. It's similar to again iterative model, but it's not iteration here. We want to develop the products very quickly, but why do you think it might take? It might be much efficient than a iterative model. Can anybody answer that question? Why do you think RAD model is efficient than iterative model? In iterative model, we have partial requirements. In RAD model, we are gathering the requirements using workshops. Here, the JAT sessions are these focus groups. When we do these sessions, all the requirements, all the that are not correct can be corrected and can be added, and the requirements are clear by the time we start developing it. That is the advantage of RAD, and because of that, because of the requirements, we might deliver a product much quicker than iterative. We again at this stage, we don't spend too much time on gathering the requirements, but when we get together, it will be less time. So there are different model phases within the RAD model. What are these phases? Business modeling phase, data modeling phase, process modeling, application generation, testing, and turnover. So in business modeling, we have information flow among business functions. So this is all the business process is captured, information is generated, and we capture all that information, and we see like how the business process is happening. Data modeling, how the data is moving from one object to other object, and how do you support it to make it successful. So instead of we going through planning or analysis or design, we are going through certain types of model phases while defining this model. And we do process modeling also. So why do you need to do so many models? You have business models, you have data models, you have process models. So each model will be different. The approach and the final result is different. In data model, we talk only in terms of data model. In business model, we only pursue business direction. In process, again process. So each direction is different. So that's why we need a modeling there. And once we generate the application, automated tools are used to facilitate construction of software. Even they use fourth generation language techniques. This is like any other coding that we do as of today. Testing and turnover. Now many of the components are defined, requirements are clearly captured, and we know what we want. Then the testing will be very easy. So once we have all the efficiencies clearly placed there, our testing time will reduce because we have all the information upfront. Any gaps will increase the timelines itself, and that there are some cases RAD models also have failed. We thought we have captured the requirements, but those are not the final requirements. In those cases, RAD model will fail. That means we have to literally do the project again from scratch, or scrap it completely, move for another project. Okay, we have half an hour left. In RAD model, what are the advantages and disadvantages of RAD model? Reduce cycle time and improved productivity with fewer people and means lower costs. Just like agile or any model where you have few people, RAD model comes into picture. Just like the one I talked about, like a CM level 2 company where you have few people there in a team, RAD model works pretty good. If you go to any Silicon Valley startup, most of them might use RAD models out there. Customer is in the time box approach mitigates cost and schedule risk because we have already planned for the time to go through these steps. That will make sure we complete within the time frame. Customer is involved throughout the complete cycle, minimize the risk of not achieving customer satisfaction and business needs. So customer satisfaction is met because we did whatever they wanted. Focus moves from documentation to code, which is good. So in other models, we focus more on the requirements and all this capturing, and that is all documentation. In here, in RAD model, we get the information. As soon as we get it, we first focus on the coding. Uses modeling concepts to capture information about business, data, and process. So why these three are defined? Because these are critical. Any project, these are the critical pieces. Whatever model still you follow, they'll indirectly you'll be following these models. So RAD model has a bigger advantage because we discuss all these processes for for the business or the data or processes model, and then we develop our requirements, and the coding can be done much quicker. What are the disadvantages then? We have accelerated development process must give quick response to the user. So just like agile, risk of never achieving closure. Why do you think we can't achieve closure? In some cases, we might go through a loop where it doesn't end anywhere. It can happen in other spiral models also. Developers and customers must be committed to rapid fire activities in abbreviated time frame. Okay, just like agile. When we talk about agile, I'll make sure you understand what I'm talking about. Requires a system that can be modularized. So if you have multiple modules, then only we can use RAD model, because we develop bit by bit. And hard to use with legacy systems like mainframe or some other components which are very old. It's very difficult to do with RAD because you can't instantly do rapid application development there, because there's a lot of processes that are involved behind for legacy systems like mainframe coding. It's very difficult. These are the disadvantages of the RAD model. The next model I'm going to discuss is prototyping model. Do you want me to continue or continue the rest of the models in next class? I don't want to give too much information and confuse you at the end. Whatever makes sense for you. Hiral, what do you think? Okay, I'm sharing this. I already shared this document to you. Go through the document and come up with questions. We'll halt it here. I mean, we covered most of the models. Tomorrow we'll be covering prototyping model. We'll cover prototyping model. We'll do agile methodology. Then that will end the session. Then we can continue with the next other set of class where we go into different types of testing. So let us halt here, go through the definitions of all these models, and come prepared tomorrow for agile and prototyping. I might ask questions from other models before we even start. Okay. Hiral and Madhavi, let me know if if you want me to go through any of the models now. Do you want me to explain or repeat any of the content? Okay, I'm halting it here. I'm going to put the video once today in another 1 hour or so on the site. It should be available for you, and I hope you don't have any problems with the videos. Let me know in case. So I'm ending the session here for today. Thank you. Good night, and I'll see you again tomorrow at 8 o'clock. And tomorrow we'll complete the models, and then we'll go into different types of testing. So once that is completed, on week 3 we'll start with the test designing and test planning. Okay, thank you and good night.